What is machine learning? Definitions and examples. Types of machine learning: supervised, unsupervised, and reinforcement learning. Hello and welcome back to the channel. If you're new here, we're thrilled to have you, and if you're a returning subscriber, welcome back to your go-to space for all things AI and machine learning. Here, we don't just explore the latest tools and trends, we break down complex topics into easy-to-understand ideas, helping you build a strong, lasting foundation in one of the most transformative technologies of our time. In today's in-depth session, Module 2 of our Artificial Intelligence series, we're diving into the fundamentals of machine learning. This episode is going to be a comprehensive guide, perfect for anyone from complete beginners to those who want to reinforce and expand their understanding of machine learning, or ML as it's often called. We'll explore what machine learning really is, how it works, the main types of learning models, and how it's already being applied in the real world in ways you may not even realize. And of course, we'll also share best practices, tips for getting started, and how to navigate your way through this field confidently. So grab a notebook, maybe a coffee, and let's begin this journey into the fundamentals of machine learning. Introduction to the topic. Before we can understand machine learning in depth, we need to step back and look at the broader context of why it matters. Machine learning is one of the core pillars of artificial intelligence, powering many of the applications that define the modern digital world. From your social media feeds and email spam filters to voice assistants like Alexa or Siri, and even in predicting diseases or stock market trends, ML is at the heart of it all. But what really makes machine learning so powerful is its ability to learn from data. Unlike traditional programming where humans define the rules, in machine learning, systems learn the rules from the data itself. This fundamentally changes how we build software, interact with data, and make predictions about the world. Understanding machine learning is crucial not just for developers, but for business leaders, creatives, and policymakers alike. It's no longer a niche skill, it's foundational to navigating the future. What is machine learning? Machine learning is a branch of artificial intelligence that gives systems the ability to automatically learn and improve from experience without being explicitly programmed. The core idea is simple. A machine uses algorithms to find patterns in data, and then it uses those patterns to make predictions or decisions without human intervention. To put it plainly, let's take a common example: email spam filters. Rather than coding rules like, if the subject contains free money then mark it as spam, machine learning allows the system to analyze thousands or even millions of emails, identifying patterns that are common in spam messages. Over time, the system becomes more accurate, adapting to new tricks that spammers might use. Another simple example is Netflix recommendations. When you watch a few shows or movies, Netflix's algorithm starts identifying what kinds of content you prefer, maybe dramas with strong female leads, or quirky animated shows, and it adjusts what it recommends accordingly. It's learning from your behavior. So, fundamentally, machine learning systems use data plus algorithms equals models that can predict, classify, cluster, or generate outcomes. Section 2. Key terminologies and concepts. Before we go further, let's clarify some important machine learning terminology. Data. The raw input, numbers, text, images, that the system uses to learn. Features. Individual measurable properties or characteristics of the data. Labels. The outcome or result we're trying to predict. Model. The mathematical representation of the data patterns the algorithm learns. Training. The process of feeding data to an algorithm to help it learn. Testing. The phase where we evaluate the trained model using unseen data to see how well it performs. Overfitting. When a model learns the training data too well, including noise, and fails to generalize to new data. Underfitting. When a model is too simple to capture the underlying patterns in the data. Section 3. Types of machine learning. Now let's break down the three major types of machine learning. 1. Supervised learning. Supervised learning. The algorithm is trained on a labeled dataset. This means the input data is paired with the correct output. The goal is to learn a mapping from inputs to outputs. Examples of supervised learning include email classification. Is this email spam or not? Credit scoring. Will this person repay their loan? Image recognition. Is there a cat in this picture? Supervised learning is typically used when we have historical data and a clear outcome we want to predict. 2. Unsupervised learning. Unsupervised learning, on the other hand, deals with unlabeled data. Here, the system tries to find patterns or groupings within the data without any predefined labels. Common techniques include clustering, grouping customers into segments based on purchasing behavior. Anomaly detection, finding unusual patterns like credit card fraud or defective machinery. Dimensionality reduction, simplifying data to its essential features for visualization or processing. Unsupervised learning is great for exploring structure within unknown datasets. 3. Reinforcement learning. Reinforcement learning is inspired by how humans and animals learn through trial and error. In this approach, an agent interacts with an environment and learns to take actions that maximize cumulative rewards. A classic example is teaching a computer to play chess. The AI tries moves, learns from wins and losses, and eventually becomes better over time. Reinforcement learning is used in game AI, robotics, self-driving cars, dynamic pricing models. Section 4. Real-world use cases. Let's explore some extended scenarios to illustrate ML's practical impact. Healthcare. In hospitals, ML is used to predict patient deterioration. Based on vital signs and patient history, algorithms flag when a patient might need urgent attention. It also assists in diagnosing diseases like cancer from radiology images faster and more accurately than traditional methods. Retail and e-commerce. Companies like Amazon use ML to forecast inventory, personalize recommendations, and optimize delivery logistics. Even small stores use ML-driven chatbots and sentiment analysis tools to enhance customer experience. Finance. In stock market trading, ML models can identify complex patterns across thousands of stocks in real time. Credit card companies use ML to detect fraudulent activity by spotting unusual patterns within milliseconds. Agriculture. ML is used in precision farming, analyzing soil conditions, predicting crop yield, and even detecting pests through drone imagery. Each of these applications combines massive datasets with intelligent algorithms to create value, reduce cost, or enhance outcomes. Section 5. Algorithms in machine learning. Let's explore a few core algorithms you'll encounter. Linear regression, predicting a numerical outcome based on input features. Used in forecasting sales or pricing. Logistic regression, for binary classification problems like predicting loan defaults. Decision trees and random forests. These create tree-like structures for decision-making. Random forests are an ensemble method that improves accuracy. K-means clustering, for grouping similar data points without labels. Support vector machines, powerful classifiers for complex datasets. Neural networks, the foundation of deep learning, used for complex tasks like image recognition, natural language processing, and autonomous vehicles. Section 6. Challenges in machine learning. While powerful, ML isn't magic. It comes with challenges. Data quality, garbage in, garbage out. Poor data leads to poor models. Bias and fairness. As mentioned earlier, biased training data can produce unfair outcomes. Interpretability. Many models, especially deep learning ones, are hard to understand or explain. Scalability. ML at scale requires significant compute resources and infrastructure. Tips and best practices. Whether you're just getting started or looking to deepen your knowledge, these tips will help. 1. Focus on the basics first. Don't rush into advanced deep learning. Understand the fundamentals of linear regression, classification, and evaluation metrics first. 2. Learn by doing. Projects help you cement what you've learned. Kaggle is a great place to practice. Build models using real datasets. Try predicting housing prices, classifying images, or analyzing tweets. 3. Use visualization tools. Use libraries like Matplotlib, Seaborn, or TensorBoard to visualize your data and understand model behavior. 4. Understand the data. Spend time on data cleaning, exploration, and feature engineering. A model is only as good as the data it's trained on. 5. Read research and case studies. Stay updated with what's happening in the field. Read about how companies are using ML to solve real-world problems. 6. Collaborate and ask for feedback. Join forums like Stack Overflow, GitHub, or Reddit's R, Machine Learning to ask questions and get feedback on your work. And there we have it. Module 2, Fundamentals of Machine Learning. We've covered everything from what machine learning is, the different types, key algorithms, real-world applications, and actionable tips to help you on your journey. Remember, this is just the beginning. Machine learning is a vast and evolving field, but with a solid foundation and a curious mindset, you're well on your way to becoming a part of the AI-driven future. If this video helped you understand machine learning a bit better, don't forget to like, subscribe, and share it with someone who might benefit. Also, drop a comment below. What was your favorite section, or what topic would you like us to explore in Module 3? Thanks so much for watching, and we'll see you in the next deep dive.